Hi students, welcome to physics class. Today we will discuss about Doppler shift. Doppler shift is defined as the difference between actual frequency and apparent frequency of sound wave is called as Doppler shift. The formula for Doppler shift is given by delta n is equal to n difference n dash. Here n is called as actual frequency produced by the source of sound and n dash is apparent frequency which is heard by the observer. Sometimes the actual frequency is greater than the apparent frequency. In some cases the apparent frequency is greater than the actual frequency. So we will take the difference n dash, that is when n is greater than n dash we take it as n minus n dash. Whenever n dash is greater than n we will take n dash is minus n. Let us consider a source. Here it is a source and here a person, that is an observer, is moving towards the source. Another case, let us consider a person who is moving away from the source. We will clearly say that when a person is moving towards the source, then his frequency, his apparent frequency will be increased. When a person is moving away from the source, his apparent frequency will be decreased. We know that the frequency is equal to velocity divided by wavelength. Here the observer is moving and source of sound producing a wave of wavelength lambda and velocity v, and the observer is moving towards the source. So the observer and the wave are moving each other in opposite direction towards each other. Then their relative velocity v relative is given by v plus v naught, v plus v naught. We will say that here the velocity changes in order to observe the change in the frequency. Here the wavelength remains constant. Let us consider an additional frequency heard by the observer is equal to v naught by lambda. Here v naught is the velocity of the observer and lambda is the wavelength. We know that the frequency is given by v by lambda. Therefore apparent frequency is given by n dash is equal to actual frequency plus additional frequency heard by the observer by writing lambda as, we can write lambda as v by n, v divided by n. By taking n to the numerator we get n plus v naught by v into n. This is the apparent frequency when the observer is moving towards a stationary source. Source velocity is 0, whereas observer is moving towards the source with a velocity v0. Similarly, when source is at rest and observer is moving away from the source, then we can clearly replace my plus values to minus, because the frequency lost by the observer, the frequency lost by the observer is v0 by lambda. This factor of frequency is lost by the observer due to the observer is moving away from the source. Therefore, the apparent frequency can be calculated as n dash is equal to n minus actual frequency minus the frequency lost due to the observer moving away from the source. Then we can clearly deduce the apparent frequency in the above format, v by n. By taking n to the numerator, we get v0 by v into n. That is, n dash is equal to n minus v0 by v into n. In the first case, we can clearly say that n dash is greater than n by a factor v0 by v. Here, in the second case, n dash is less than n, because here n is less than by a factor. N dash is less than by n. N dash is less than n by a factor v0 by v into n. So, here the apparent frequency is less than the actual frequency. In the first case, the apparent frequency is greater than the actual frequency. This is the procedure in order to deduce the apparent frequency when the observer is moving towards the source or moving away from the source. Thank you.